Hi everyone! Welcome to our final presentation, and today we're excited to present a first look of our product, Cody, a COVID-19 haptic distancing system. This is an idea from our client and technical advisor, Dr. Stephen Knudsen, and it was implemented by the ECE 492 capstone design team of myself, Amy Ho,
Ayushi Patel.
Gaurav Sekhar.
And Ibrahim Ali.
Social distancing is one of the most effective ways to prevent the spread of the COVID-19 virus, but it is easier said than done. Cody was created as a way to gently remind users to maintain social distancing around other Cody users. The project expectations were to build a wearable haptic device in combination with a smartphone application to accurately measure the distance to nearby haptic devices and provide haptic feedback. The goal for the distance measuring algorithm was to have an error range of plus minus 10 centimeters. We were also expected to implement a geofenced area where the device would be disabled. To meet these expectations, Cody consists of a wearable haptic device and an Android application communicating via Bluetooth Low Energy. Our algorithm achieved an error range of plus minus 20 centimeters. Additionally, the system is capable of geofence area selection and multiple user support.
Now, let's walk through Cody's initial device pairing process. First, we will launch the app. We are greeted by the initial connection screen. When the user clicks Scan, the application finds nearby Cody devices to pair with. The user selects their device, and it is now paired. After pairing, the application will continually scan for other Cody devices. If the user wishes to set a geographical area or a geofence, where they will not get alerts from Cody, such as at home, they can do this in the settings. Here, the user can enable the geofencing function and set their current location as the geofence area by clicking on the Set button. Then, once the user clicks Save, the geofence is set and enabled. After that, the app will show the user that they are in the geofence area, stop scanning for nearby devices, and will not send alerts to the user. The user can also go back to the settings and disable the geofence. Finally, if the user has to replace their Cody device or connect to a different device, they can hit the back button to return to the pairing screen. We will now move to live demonstrations of Cody in action. All demonstration footage was filmed in accordance with all COVID-19 restrictions.
To start off, we see Cody in action when two users approach each other for a conversation. When Ibrahim approaches Amy, who's sitting on the bench, they are initially at a distance of more than 2 meters. As Ibrahim begins to come within 2 meters of Amy, their haptic devices detect each other as within 2 meters. As you can see, the LED on the device turns blue as the haptic motor vibrates. Alerted by the haptic device, both users immediately distance themselves from each other. Once the users distance away from each other, the devices stop vibrating.
Here, Amy and Ibrahim are standing less than 2 meters away from each other. However, they're still following safety precautions since they are separated by a wall. The wall introduces noise to the device's beacon and diminishes the BLE received signal strength indicator, or the RSSI value. This causes the distance measured by the device to be greater than 2 meters. Therefore, the Cody system does not alert the haptic devices to vibrate, which is the desired outcome. In this scene, Ibrahim is sitting in sub with Gaurav, a close contact that he does not have to socially distance from. He wants to set sub as his geofenced area so he does not get any alerts about social distancing. He enables geofencing, sets his current location as the geofenced area, and saves the settings. Then, the device detects that Ibrahim is in his geofenced area, so it displays the status and stops scanning for other nearby devices. Now, Ibrahim starts walking to leave his geofenced area. When he reaches outside, the smartphone application correctly detects that he is now outside of the geofenced area. The app will now restart scanning and change the status banner to show that it is detecting nearby devices.
Now, we'll elaborate on the accuracy of the distance measuring algorithm. To begin with, our two users, Amy and Ibrahim, are separated by a distance of 300 centimeters. Amy standing still as Ibrahim approaches her incrementally. Ibrahim starts off by moving from 300 centimeters to 280 centimeters. As we can see, the device does not vibrate, as indicated by the LED remaining red. Next, Ibrahim moves another step closer to Amy. He is now 250 centimeters away. Once again, the device does not vibrate. Next, he moves 30 centimeters closer and is at a distance of 220 centimeters. The device still does not vibrate. Next, he moves to the recommended distance of 200 centimeters or 2 meters away. Since we are at a safe distance, the device does not vibrate, as expected. Finally, Ibrahim moves within the 2-meter radius by moving to a distance of 180 centimeters away. As we can see, the haptic device provides feedback, as indicated by the LED turning blue.
We will now discuss the results and outcomes of our prototype implementation. Let's start with what we accomplished successfully. We were able to successfully connect and disconnect the smartphone with the haptic devices via BLE. After connecting, we successfully implemented an algorithm that was able to detect other haptic devices within 2 meters with a plus-minus 20 centimeter error radius. We were also able to use GAT to write data to the paired haptic device. We programmed the firmware of the haptic device to make the motor vibrate when the device received an alert from the app. Additionally, the smartphone application included geofence functionality using Google's third-party APIs, which disables the application's scanning functionality in the geofence area.
Next, let's go over what did not work as expected. Our distance measuring algorithm was not accurate enough to within the plus or minus 10 centimeter error radius that was stated in our initial proposal. Also, the geofencing functionality was not very accurate in detecting location changes, since Google's location APIs limited our ability to determine the user's location while the power saving mode was enabled.
Next, let's go over the possible extensions to our system that can be implemented in future iterations. The first extension is the addition of a safe list to our system. Since users are not required to socially distance themselves from their close contacts, it'd be useful if they could leave the geofenced area together and not trigger each other's haptic devices. Additionally, in order to improve battery life of the haptic device, we could lower its beaconing rate within the geofenced area since scanning and alerts are disabled. Another enhancement for our product could be the addition of contact tracing. To implement contact tracing, we could track a list of devices that caused alerts within the last 2 weeks. To improve the accuracy of the distance measuring algorithm, we could explore dynamically updating the environmental factor to match the current environment and manually calibrating the transmission power from 1 meter away.
In conclusion, we implemented a COVID-19 haptic distance measuring system. Social distancing is one of the most effective ways to prevent the spread of the COVID-19 virus. In order to maintain social distancing, we made a haptic device that works in conjunction with an Android application that scans for other nearby haptic devices. The device vibrates when the app detects other devices within a 2-meter distance. We used BLE as a means of communication between the smartphone app and the device, and we implemented a custom distance measuring algorithm based on the received RSSI values from nearby devices. Finally, we implemented a geofencing feature using Google's third-party location APIs, where the app will be disabled within the selected geofence. We hope you enjoyed our final capstone presentation. Thank you for listening, and we are now open to any questions.